Okay, here is our original graph again. I've just written in what I know to be the right answer into a folder and hidden it so that we can't see it, because that's going to be the kind of experience that you have when you do these yourself. You'll be able to see a graph, and you're going to be asked to come up with equations for that graph. Here are the equations that we came up with in the previous video for this graph, except that in this form, in this case, because I'm in Desmos, I have to type it in as a pair, a coordinate pair, right? So my x coordinate is 6 cosine t plus 4 cosine 5t, and my y coordinate is 7 sine t plus 2 sine 5t. All right, so I've typed that in, and when I hit go, I get a red graph on top of my blue graph. Now clearly my red graph is not the same as my blue graph. It has all the right components, right? It has a loop in all the right places, and the loops kind of are going in the right direction. They're not looping outside the graph, they're looping inside the graph. So we're not too far off. We have the right general pattern, but we need to figure out what we can do to tweak this graph to fix it so that it completely overlies the blue graph. That's going to be your goal with this project. One of the things you can check very easily is to see whether or not your blue and red graphs go to the same extremes. In the x direction, they do. They go to -10 and 10. Right? They both go to that same value. In the vertical direction, however, the blue graph goes all the way up to 10 and all the way down to -10. And the red graph only goes up to 9 and -9. So let's see if we can find those numbers here. If I take a graph of amplitude 6 and I add on top of it a graph of amplitude 4, which is what we've got here, I'll end up with a graph of amplitude 10. This is my x coordinate. X goes all the way to 10, which is what it should do. If I take a graph of amplitude 7 and add onto it a graph of amplitude 2, I'm going to end up with a graph only of amplitude 9. And that's what I've got here. So part of the problem is that this 7 plus 2 equals 9, and I need these two numbers to add up to 10. So let's just try changing this one to, well, we wanted the amplitudes of these first two things here to be the same. So let's try changing this to a 6 and a 4. Oops, 6 and a 6, 6 and a 4. All right, now my graph goes to the same extremes, and in fact, it's very close. My loops are just too big. So now what I want to do is play around with how I get 10. I can do it with 6 and 4. I can do it with 4 and 6. Well, that doesn't look like it's helping. Yeah, that's made a mess. So that's not right. Let's put it back to 6 and 4. It takes a little while. And so that means that having this number out here being smaller, kind of pushed smaller than this one. Right, I had a 4 and right now the first number is bigger, the second one is smaller, and that's because when you look at the graph that I came up with, the pink graph, which was my base graph, with the white graph on top of it, the white graph was only a little bit bigger than the pink graph. The pink graph appeared to have an amplitude of 6, and we only had to add a little bit on top of that. So we kind of want this number here to be larger than this number here. So how else can you get to 10? Well, how about 7 and 3? 7 and 3. Well, that's looking closer. Let's try changing this one to 7 and 3. 7 and 3. And there you have it. I can't see the blue graph at all anymore. So that's my answer. Is it the right answer? Well, yes, it is, but it's not the only right answer. So as you do this activity, you may find that the interface that we're using tells you that this is wrong. It gives you a red X instead of a green check mark. But if your graph is completely covered, then you don't need to worry about it. Just hit submit and go on. And once a day or more, once you start this project, I'll be checking. And if I see this and you don't have credit for it yet, I'm just going to give you the points. Let me show you what I mean. This graph, this red graph that we came up with the equation for, clearly overlies the blue graph. If I turn it on and off, you can see the blue graph underneath it. All right. Let's check and see what the actual graph was, what the equations were for the blue graph originally. We have a cosine plus a cosine for our x, and a sine plus a sine for our y, whereas the original graph was a sine plus a sine and a cosine plus a cosine. But they're the same graph. When t equals 0, sine of t equals 0, 7 times the sine of t equals 0. Same thing here. So my x-coordinate is 0. This graph started here. We started over here. And that's the difference. That's why the equations are different, but they actually produce the same graph. Exactly the same graph, and very similar but reversed coordinates for the graph. Sometimes the equations can actually be much more different than that. The point is, you would get full credit for this. The closer we get to the end of the term, the more frequently I check these. So at least once a day once you start, and much more often than that as we go on, you'll be getting points for this answer, even though you originally didn't get the points for it because the system doesn't recognize that it's the same thing. I would invite you to put both of these answers, both forms of this answer, into the interface in the tutorial so that you can see what happens when you type in a so-called wrong answer but get a correct graph. And then you can just self-correct if you want by typing in this answer or typing in this answer rather, and the system will give you the points. Now, this tutorial isn't actually required, so any points that you earn doing the tutorial don't actually affect your grade, but it'll give you an idea of what the experience is going to be like when you do start working on the project that is for points. One thing I'd like to comment about using Desmos is that you won't normally have the blue graph on Desmos. You'll see the blue graph in our interface. You won't be given the blue graph in Desmos. I mean, Desmos is just going to graph what you tell it to graph. So it's going to graph a graph, and you have to hope that that's close enough to the graph in the interface. But if you type it into the interface and it's not quite right, then you'll be able to adjust it now based on what we talked about here. I'm going to do another one of these for you. I won't completely finish it out because the point of the next one is to see how far along in the process you can get on your own. What I will do is I'll start with the graph that the interface gives you, and I'll get you started. I'll show you in the next video that I use my normal software for. I'll show you how to get started on that one. It's going to be a similar process, but it'll just provide you with another opportunity to see somebody else working through the process of doing one of these. So that's going to do it for this video, and I'll do another example or part of another example in the next one.